We're going to continue on with our discussion of Java Stream's non-concurrent collectors, focusing on the API. And it's a fairly simple API, but it's got some kind of cool features. And one other thing that's worth noting is that the same API is used for both concurrent and non-concurrent collectors. So once you understand the basic ideas, it's very similar, though not entirely identical for reasons we'll talk about in just a second. So the collector is an interface that defines three generic types. The first is type T, which is the type of element that the stream provides, which could be all kinds of things like longs and strings and doubles and search results and employee records or whatever. Then there's also A, which is the type of the so-called mutable accumulator object that's used to collect elements. This could be a list or a map of T, which is often, though not always, implemented by an array list. It could also be a hash map under some circumstances, and so on and so forth. Usually it's a list of some kind. And then R is the type of the final result that's going to be returned after all the collection and processing is finished. And this is typically also a list or a map of type T. The type of R, return, and A, accumulator, may or may not be different, and they're often the same. In fact, we'll see when they're the same, there's ways you can actually eliminate some phases here with the finisher, as we'll see. There are 5 primary methods defined in the collector interface, and we're going to be talking here about non-concurrent collectors. When we get to the concurrent stuff later, when we get to parallel streams, we'll talk about the other variants of this. The first method is called characteristics, and you can think of this as metadata. It provides additional information that the streams framework uses to optimize its behavior internally when it's processing a collector. There's 3 different flags that can be provided as part of the characteristics set. You can see it's a set. The first is unordered, and that simply means that the collector is under no obligation to preserve in counter order. Remember, in counter order is the order that it sees from left to right. And it turns out that a collector may preserve in counter order if there's no additional overhead. So for example, if you're dealing with some kind of a list, then it'll typically put it in counter order, even if you don't tell it to, even if you say unordered, it'll still just put it in order because that's the easiest thing to do for a list. But it doesn't need to. And there's some data types for which this can be a bit of an optimization. There's also the concept of so-called identity finish, which says that the finisher, which we'll talk about in a second, is the identity function. In other words, whatever we've been accumulating is just going to be returned back as the result of the collector. And therefore, we don't have to call the finisher at all. It can just return null. It's essentially a no-op. And then the third and final characteristic is concurrent. And this one's really important. This means that the accumulator method will be called concurrently on the underlying mutable result container. And this you actually have to spend some time thinking about. Now, for a non-concurrent collector, don't set concurrent. But if you do have a concurrent collector, because you're planning to use it in a parallel stream, then that means that the mutable result container must be properly synchronized. You have to have some kind of a synchronized list or synchronized collection. There are various ways to do that, but it has to be synchronized because it'll be called simultaneously or concurrently from multiple threads as the accumulation process is taking place. We'll cover that later. We're not going to talk about concurrent collectors. We're just going to talk about non-concurrent collectors, so there's no need to set concurrent. And there's no need to use any locking. You can set any or all of these characteristics using various techniques. The most common one, or very common one, is to use enum set, which collects up a bunch of enums into a set of being the factory method that makes the enum set. And you can see here that what we're doing is we're giving all the various characteristics, concurrent, unordered, identity finish, and so on, making an enum set, and then we're turning this into an unmodifiable set. That just means that it can't be changed because we don't want to allow the caller to modify this in any way, shape, or form. So that's what an unmodifiable set is. It's a type of set that doesn't have operations for mutating or modifying the set. All right, that's characteristics. That's the metadata. Then there's 4 other methods we're going to talk about that are also very important. First one is supplier. And the supplier returns a supplier, which is a type of functional interface defined in Java, modern Java, that acts as a factory to generate an empty result container. So that's basically kind of like a virtual constructor, if you will. And a very, very common thing to do if you have a list or an array list as the type of the mutable result container is to have the supplier return the array list new constructor reference. And when this supplier is called, it'll make an array list. So that's a very common way to do things here. The accumulator returns a BiConsumer that adds a new element to an existing result container. So you can see here we have BiConsumer, which takes a list and an integer, if you happen to be parameterizing this with integer. Otherwise, it would be double or search results or employee record or whatnot. And you can see here what we're going to do is we're going to pass in the add method reference for a list, which takes essentially a it's a BiConsumer in that it's going to take an integer and return a list. A non-concurrent collector needs no synchronization, so list : add works just fine. If this was a concurrent collector, we'd have to have a different kind of list, something that knew how to deal with things in a synchronized, thread-safe manner. The combiner returns a binary operator that merges two result containers together. Now, for some strange reason, there's no single method for doing this in Java, so you typically have to write code like this or define another helper method somewhere. So you can see the combiner here takes two lists, one list and another list, and it adds another to the end of one, and it returns one. And we do this just to sort of trivially maintain in counter order, because we're going to essentially append another at the end of one. Remember, combiners are not called for sequential streams. And then we have finisher, which returns a function that converts the result container to the final result. So there's a couple different ways to do this. Function identity just returns the underlying accumulator as the finisher result. If you think that's a waste of time, which it often is, then you can set identity finish, which says don't even bother calling the finisher at all because it's just going to return the accumulator, and then you can just have it return null. And so the whole thing will be skipped altogether. So that's just a little optimization that is going to occur if identity finish is set as a characteristic. There are lots more interesting, or there are other more interesting ways of writing a finisher. So often it's just sort of a no-op, but especially if you're doing something that involves lists. But you can also do much more interesting things. And we will talk about this when we talk about the upcoming completable futures framework, where we're going to make the finisher do all kinds of cool things, where it's going to essentially return a completable future that will complete when all the other asynchronous computations are done. So we'll talk about that when the time comes. But the point is that you don't have to make it as boring as just a no-op. You can do very interesting things. OK, so that is the end of the overview of Java non-concurrent collectors and how they're defined in Java streams.